All right. Yeah, welcome back to this series where I'll be talking about the compiler I designed for my MSc thesis. In this particular video, I'll be talking about the addition to knowledge that was achieved in this particular research. Yeah, this is the phases of a compiler, a diagram showing the phases of the compiler. This by standard what has been around circulating in the academia, different version of it. Now you have the analyzer which breaks down the analysis stage of the compiler, which compromises of these three steps: lexical, syntax, and semantic. The analysis part of the compiler just focuses on breaking down the programming language, and the synthesis part of the compiler focus on building up the programming language. Anyway, one of the major additions to knowledge while doing this research was the improvement of this standard diagram that has always been in circulation. Now, from here, we can see that the symbol table and every other stage of the compiler still report back to the code optimizer and the code generator. Practically, this is wrong. This is this won't occur most of the time. Because why? Uh, the code optimizer and the code generator don't report back to the error handling. Any error that occurs here at the code optimizer and code generation stage is likely going to crash the program. That is the whole application running. So a more improved diagram is this, which is practically attainable. And also for a compiler, the output of a compiler is never a machine code. That is one thing that has been misunderstood in the academia. The output of a compiler is never a machine code. The output of a compiler are codes in assembly language. From this point, the compiler has done its job. What picks it up from here is an assembler. And for most operating system, an assembler is always shipped with it. Yeah, for Microsoft operating system, it is being shipped with an assembler. So once a compiler gets to this point, and generate a code in assembly language, the compiler has done its job. A compiler does not output machine code. Also, at this stage of the code optimizer and code generator, they don't report back to the simple table or the error handling practically. Because any error that occurs within these 2 points will likely crash the program. There's no error handling a user wants to write to yeah, to handle the errors that occur within these two stage. And also, it has at this point, code optimizer and code generator, they don't communicate back with a simple table. They have, they have already gotten every information they want from the simple table from the intermediate code generator. So this alone is an expose of what this research has been able to establish and achieve. So technically and practically, the error handler and the simple table manager don't communicate with the code optimizer and code generator. That is number one. Then number two, a compiler does not input machine code. This is totally wrong. A compiler outputs Rather, a compiler does not output machine code. This is totally wrong. A compiler outputs code in assembly language. Just for a little bit of read up, let's say code the input are code written in the broken programming language. That's the programming language and the compiler we are going to be developing this research. And the outputs are codes in assembly language. Very, very basic. Very, very basic. Because technically compilers outputs are usually assembly codes which is automatically passed to the assembler. The code optimizer and code generator stage don't really feed back to the simple table, and the exception or error generated at these stages are automatically handled within the stage. It does not give feedback to the error handling model, neither does it give feedback to the user, because the user cannot really do any correction at this stage. Yeah, in each of these stage while we within this research, each code optimizer and the code generator will have their own error handling imputed in it, because we any error that occurs within these two stages, you don't really want to show the user. That's one of the expose. And that's one of the addition to knowledge in this research. Thank you for watching this video.